When I look at a question like this one, I know it freaks you guys out. Completely and utterly freaks you guys out. If I ask you to prove R of C equals to 2 times by R of C over 2, this is what I want to prove, RTP. You guys know that maybe from Euclidean geometry. Okay. Now, ladies and gents, here comes the thing. If I want to prove left equal right, how did I do it in trigonometry? I started left and manipulated the living daylights out of that thing. And then I went over right, and I also manipulated the living daylights out of that expression to eventually get them equal. So I'm going to start left and look at R of C. What does R of C mean? Okay, R of C means I replace every x in my expression with C, so I just substitute in. So in other words, it's going to be C squared, C remains C, minus C over 3. Now this, if I simplify, if I put it over 6, it's 3 and 2. So it's 3C minus 2C, which is just 1C. So this leaves me with C cubed over 6. Is everyone all right with that? Okay. Now I have now manipulated the left-hand side completely. So what am I going to do now is I'm going to go over to the right-hand side and I am going to look at doing 2 times by R of C over 2. Now this 2 just remains in the front. I'm not going to do anything with it. All I'm going to do with the R of C over 2 is I'm going to replace every x with C over 2. So this is going to be C over 2 squared, C over 2 minus C over 2 divided by 3. Because I replaced every x with C over 2. Everyone all right with that? So what am I going to do now? I'm going to say, well, this is 2C squared over 4. This is C over 2 minus C over 6. 2 goes into 4 twice. So I'm left with C squared over 2. Put this on the LCD, which is 6, so times by 3 and times by 3. So this is going to give me 3C minus C, which is 2C over 6. Okay. Which that 2 and that 2 cancels out, leaving me with C cubed over 6. They are equal to each other. Magic. Okay? Therefore, R of C is equal to 2 times R of C over 2. Ladies and gents, do not overthink this. Some of you guys were trying to go, but sir, how could this be equal to that? I cannot see it. I'm like, guys, chill. Work left, work right, get them equal. If it was 1 mark, I would have gone, okay, cool, you should be able to see it. But this is a 4-mark question in the exam. So you shouldn't just be able to see it. You guys have to learn to look at mark allocation. Now, I wrote out every step. You can make it much simpler if you know your maths and you can go all quick. But it's fine. Let's go just the way it is. Now, ladies and gents, let's quickly have a look at the second part. Now it says r accent of x. R accent of x is the strength of the drug, or this is used as a measure of the sensitivity of the, I'm going strength. The sensitivity of the, is the sensitivity of the body to the drug. Now here comes a snag, because now they're asking you, where is the sensitivity of the drug minimized? Okay, so now I'm going to go and think, the moment I think about minimum, I must think about or maximized, sorry. When I think about maximum, what am I thinking about? How do I determine a maximum? Derivative. But now be careful. Then they're asking you, when is the sensitivity maximized? So I've got to take this expression and derive it again. So I'm actually going to go towards r double accent of x must be 0. Not r accent of x, because r accent of x is the sensitivity. When is the sensitivity maximized? And I've got to differentiate that expression and put it equal to 0. So let's quickly work through this. But there I now have all of the mountains standing in my way. I first of all need r accent of x. But to get r accent of x, I've got to first go to r of x, and I've got to simplify. C over 2 minus x over 3. So if I simplify this, it gives me c over 2 x squared minus x to the 3 over 3. Now I can get an expression that gives you the sensitivity of the drug. So this, if I simplify, if I differentiate this, 2 times pi a half is 1. So I'm left with cx. 3 divided by 3 is 1 x squared. And there I now have the sensitivity. I have an expression that measures sensitivity. So now I've got to go and differentiate this. So if I differentiate this to get it to a maximum, it becomes double accent x. So this is just c minus 2x equal to 0, because it's at a maximum. So x is going to give me c over 2. Okay? And there I have my value of x, which will determine such that that the sensitivity is at a maximum. Okay. Now, ladies and gents, I am being very honest. This takes some insight to get used to. It's not something that you're going to do once and just go, I've nailed it. You've got to learn to work through old exam papers, work through old tests, so that you get used to the way they ask questions. Guys, it doesn't help if you've got all the knowledge in the world, but you don't know when and how to apply that.